All right, so it's 3.45 problem. Okay, so the game is x and y have this joint distribution. Now it looks weird because x doesn't show up in it. Okay, and what we're saying is x has to always be less than y. It's pretty clear there, and then 0 elsewhere. And you're like, okay, cool. So for instance, you could do a variety of things, but we know that this, what we're saying is this, that 0 to y, 0 to 1, we know this has to equal 1 because it's a PDF. That's what we're saying, right? Okay, well, what we want to know is, oops, something is wrong. That was cute. One moment, please. Literally. Just fix the thing, please. Just give me my thing back. Piece of crap. Alrighty then. So I did click there. Well, reload it. Thank you. Okay, that's all I wanted to know. Alright, so anywho. You worthless hippie. Oh. Yeah, okay, so start normally. Yeah, I don't care. Okay, here, friends. I'll tell you what we're going to do. We're just going to go to a new page. What do you think about that? Huh? All right, so I'll write it down again. You can't fool me, computer. And 0 less than x less than y less than 1. Cool. Well, what I want to know is what's the probability that x plus y is greater than a half? Okay. Now, I feel like I've seen something like this before. Kind of, okay? So what I'm going to do is I'm going to take this guy, x plus y, greater than a half. I'm going to flip it inside out. I'm going to do a half, x plus y. Now, it didn't change anything, right? Now, just bear with me now. Now, what if I did this? What if I did... I could do this, correct? In other words, I could have solved it like that. Well, that's true. You could, Jay. That's good. Why would you do that? Okay. Well, now think about this for a minute now. We need to have x plus y needs to be greater than a half. All right. Nice. So if you tell me what x is, then I could kind of tell you where to go in that case. All right. Now, could x still be 0? Yeah, it could be. But then that would force y to be bigger than a half, yes? And so think about these things as you're going along, okay? So as we do these, just kind of be aware of that. I feel like right now, though, this would have to be true, yes? That idea that we still have this bound on the top end of the thing. But the idea that whenever I pick an x, okay, obviously it has to be less than y still from before, okay? And it has to be, obviously... it has to be, well, in this case, honestly, it'd have to be, it would have to, when I plug it in, rather, 0 obviously is the lowest it could ever be, okay? So that's one way to think about it. Or, I guess, what I could also do in this case, I could also stop x like this and do it this way as well, okay? And, yeah, so all I care about is the x plus y needs to be bigger than a half. Okay, so I think what I'm going to roll with is the way I had it written the first time. Like that. Okay, I'm going to pause you for just a second. Okay, so let's think about this for a minute now. Again, so I can write this a couple different ways, but I'd kind of like to be able to pinch, you see, x between something. So if you look at this, you're like, okay, that forms, if you will, this forms a lower bound for x. Our upper bound for x is y itself. You with me? So the biggest I could ever be is what y is. Okay, and so let's think about this for a minute. So if x, for instance, if x were 0, okay, then what would y be? Well, y would be a half, obviously, right? And if x were a quarter, then y would be a quarter, right? And so on and so on and so on. And that's at the bottom end of things, of course, yes? And so when you look at this, well, you're like, well, okay, so that's along the bottom end of these things. Well, where would that be? Okay, well, if I do that, 0, a half is here. 0, 1/2. quarter is here. Oh, leave me. Oh, damn it. There and there, rather. Okay. And then, of course, you get half and 0 right there, right? So what is that line? Well, that's the line half minus y, right? Like that. Okay. And then clearly we're also talking about the line y equals x, right? That is this line here, y equals x. We're talking about that line in between them. Another way of thinking about this is in the looking down the xy plane. Think about it. So we know we've got some planes going on here, but we're saying that 0 is less than. So this guy right here, this is the line y equals x, and we're saying that y is greater than x. So we're up into here. So we're up in these values up in here. Okay, and so we're talking about the values in there. So if you think about it, oh, sorry. That's true if I'm doing it in terms of y equals x. But let's turn around down here. We're saying x equals y. That's this guy, right? That's x equals y. A half minus y is this guy. And we're saying that we're between those guys. Remember, we're in the x, y direction. We're out that way. Yes? And so just picture that because these are x equals functions. So they're written the other direction. Not a big deal. So again, we got that from saying this is a lower bound for x. This gives us an upper bound for x. So there we go. Okay, so it's a half minus y to y, 1 over y dx. That's clear. Then dy. Well, what can y do? Well, y could do anything except it can't really do anything. It couldn't be 0 because if you think about it, it can't be 0. We're not talking about this value. Y can't be 0 because y has to be strictly greater than x, yes? So this one here I have a slight problem with. If x was a quarter, that wouldn't work, right? If x was a quarter, we couldn't be bigger than a half, yes? So actually I always have to be a skosh. Y would have to end up being a skosh bigger than a quarter, like 0.26, for instance, or something to pull that off. And if you look at it, that would make sense. So we're up in this value up in here. So what does that say to me? That says that the smallest that my y can ever be is 1/2, and then 1/2 to 1. Okay, and I've punched that in right there, and lo and behold, there's your answer. Slicker than heck. The hardest part about that guy is setting up this piece here. But don't be afraid to try to draw some pictures, and then also listen. You've already got a bound for x. Well, you kind of got a bound for y as well. But you got a bound for x. To me, x depends on y. So I'm going to keep that relationship, and I'm going to go dx first every time when I have the chance to do that. Okay. Let's draw this picture again here a little bit more. I'm just going to draw it. So I'm actually going to use Desmos to sketch that picture, because you can actually do it in Desmos a little better. So if I do that, desmos.com. And it's just too late at night to be trying to graph in terms of x equals and stuff. So I'm not going to try. So I'm just going to go x equal y. I'm not going to say x equal. I'm going to say x less than y. So that's up in there, yeah? And then we're also going to graph the x plus y needs to be bigger than 0.5. Bam. And where do they overlap? They overlap up there where they overlap. Except, of course, what do we know? Well, we know that x is bigger than 0. And we know that y is bigger than 0 as well. Although I guess I could show that. I could show that as well. Sure, why not? There. Uh-oh. Maybe if you're on the right line, it would work, stupid. There you go. And so you can see that we're up in this region up into here. Yeah, where they overlap. Now be careful because we also have to have y less than 1. Right? And we also have to have x less than 1. So you can see it's this little itty-bitty triangle up into there. Yes, that's the piece that we're talking about. Okay? And so that's how that game's going to get played in there. It's kind of how it works. What a guy can do, actually, it's kind of fun. My buddy taught me this years ago. Once you get past the annoyance of it, it's really cool. At first, you're like, no, that's backwards. Basically, what he's doing, he shades everything backwards, and so that what's left is white instead of dark. And it makes your life so much easier to see. And then, of course, you also have the x is greater, we'll say greater than 1 as well. And so it's everything in that white region is what we're interested in. Okay. And so everything in that white region, oh, I'm sorry, that's part of my problem. It should be greater than 1/2. Oh, it was greater than half. Yeah, so we should be good to go. And so we're talking about in that region in there, and that's how you get those values is coming out of them. Okay, that's the game. And so I don't know if that's helpful or not. Sometimes it is. Sometimes it's more confusing. That's the game. Okay, and yeah, hope that helps. Okay, all right, bye.